midpoint and segment constructions. I will calculate and construct midpoints and segments.
Lovely. Let's go ahead and get right into it. Let's start off with midpoints. What do you think midpoint means? Middle. It just takes some time. Little point, you're in the middle of the line, halfway between the two endpoints. It's hard to sing that song and write something completely different at the same time. I'm just saying. So the midpoint is the point that is exactly halfway between the two other points.
Miss, I love how you have a song for that.
I have a song for it.
Very creative and original.
Thank you. I'm trying really hard to finish the lyrics for it and then find the karaoke track on YouTube, and then, yeah, we'll have a music video. Mixtape. You can put that playlist on. I'm studying, Mom. What? You're jamming out to you? I'm studying for my geometry test. I had some caffeine not too long ago, okay? I'm a little wired.
It's totally fine.
You forgive me this time, but I better not let it happen again, right? All right, so we're going to draw line segments. I need the names for these 3 points. If I did not pick your points, I may have heard it, but this is what my hand decided to write. And save those points because I will need them again later. All right. So if we wanted to write and say that A was that midpoint for this line segment, we would write and say it this way. A is the midpoint of line segment RM. And that would be how we say it and how we write it. Provided A is the midpoint, exactly halfway between those 2 points. What do we know about those segments on either side of... Bless you. What do we know about the segments on either side of the midpoint? They're congruent. And I love that you used our word from yesterday. So let's go ahead and make that our recall, just so that we can write it down one more time. Congruent meaning same size, same shape. And there's the little marking that we will use in all of our diagrams, showing that segments are congruent. They have the same measure. Lovely.
I put shame.
Shame, poor size. Just like with distance, we can talk about midpoints on a line in 1 dimension and on a plane in 2 dimensions. We're going to deal with the 1 dimension first. So I'm going to zoom in kind of tight here on the line portion, and then we'll scoot the paper over. Names for these points, go.
A and W.
It's all right. We'll have another chance on the next diagram. All right. And just like with distance, we can use the coordinates to arithmetically, using addition, subtraction stuff, to calculate the coordinate for the midpoint. In order to calculate the coordinate for the midpoint, I need to know the coordinates of the endpoints. Because we're doing a formula and we want it very general, we're going to use our go-to variables. Okay? In 1 dimension, the formula for the midpoint of a segment, in this case, we're looking at segment ZN, is going to be given by the formula that says take your x coordinates, add them together, and whatever you get, divide by 2. Poof, formula. So far, so good? Making sense? Okay. Let's look at it on a plane. Plane, recall, is 2 dimensions, so we have a sense of length. All the coordinates of the length dimension, we will use x as the variable. We have a dimension for width, and all the coordinates of that we will use the y variable. And we will have some sort of line segment with 3 points. I need the names go.
R.
Hey.
F.
Aw.
The Royal Air Force.
Wow.
RAF. And because this was midpoint, these pieces were congruent, yes? And because this is midpoint, these pieces are congruent, yes? All right.
Yes.
All right. The formula, oh, I need to put coordinates.
Oh.
Okay, we have coordinates now. The formula for midpoints in 2 dimensions is given by this weird looking thing right here. Let's compare and contrast these formulas real quick. What seems to be similar?
The first
Divided by 2.
The first part that we're dividing by 2, that we're adding coordinates and then dividing by 2. What's the differences? We have a y in the formula for midpoints on a plane. Bless you. Why? What's the reason? What is the reason that we have this extra variable in the midpoint for a plane?
It's plane is more than just a line.
Because it's a plane, it's a little bit more than a line. We have more dimensions that we have to keep track of. 2 to be exact. Very nice. All right, feeling comfortable with where we are getting these formulas from? Let's put them to use. Please pull out your study guides. Look, all pro. It's not going too fast or anything. Oh, that was awesome. Getting better at this every day. As I adjust my jacket. If only I had face cam, that would have looked really cool. All right, working on it. Notice on your study guide, the first thing you see, as always, are the formulas. All right, let's go on to question number 1. We need to use the number line to find the coordinates of the midpoint of each segment. First off, on number 1, how many dimensions?
1.
1. So which formula should we be using?
First one.
The very first one. The formula that says the midpoint of line segment CE is equal to x1 plus x2, all of that divided by 2. So what is the coordinate for C? -4. And what is the coordinate for E? 2. Which point is x1 and which point is x2? C, you want C to be x2, okay? That's going to force us to make E x1. Can you see where the substitutions happen? All right, I'm going to go ahead and do them really quickly for you.
What is E equal?
2.
2.
I caught myself. and Destiny nods at me like, you got it. I forgot the negative on the 1.
Yeah.
Almost did. Correct it. All right. Really easy? Really good? Beautiful. Let's go ahead and look down at number 9. How many dimensions? How do you know? Because we have an x and a y. Each point has 2 coordinates. Perfect. So we need to be using the formula for midpoint in 2 dimensions. That's the formula that looks like this. Which point is x1, y1? A or B? A, okay. It didn't matter which one you picked because I heard that kind of question in your voice when you said that, like, A, is that the right one? Sure, yeah. If you were thinking B but were worried that it would be wrong if you said it, you weren't wrong. It's right too. You get to choose. Yeah, and you're always right no matter what you choose. Hallelujah. Can you see where the substitutions happen? All right, go ahead and do it. Now mine looks weird because I'm leaving spaces to do the colors, so I'm not changing pens so often. All right, we all feel comfortable about where I got those numbers?
Yes.
All right. I'm so glad that worked. I know we went through a lickety split and it seemed really, really easy, but because I want to spend some time on this last one.
Wait, that was off for number 9?
That was it.
Oh, God.
Sun nap. The directions for number 9 read, find the coordinate of the missing endpoint if we are given that P is the midpoint of this line segment NQ. This means we have a setup that looks a little something like this. And I have coordinates like this. How many dimensions? 2, because each point has how many coordinates? 2. So we need to use the formula for midpoints of a segment in 2 dimensions. Again, when you're doing an open response kind of thing, like all your practice, skills practice sheets, write your formulas each and every time. What's the name of the midpoint? What's the name of the midpoint of line segment NQ? P, because we drew it and because it told us to. That's why we drew it. So I can change this formula into P, and then I can rewrite my formula so that I know what it is that P needs to stand for. And now I can start my substitution. I have the coordinates for P, don't I? Yes. 3 and -7. Now, we need to figure out which point is x1, y1, and which point is x2, y2.
How come you redrew it like 50 if it's already on the vector equation? How come you already...
Why did I rewrite it here?
Yeah.
Because the only change I wanted to make was to give the name of the midpoint.
Oh, okay.
Thank you. So in order to continue on and continue our substitution, we need to figure out which point is x1, y1, and which point is x2, y2. Can we use P as one of those 2 points? No, because P is already taken up by the midpoint, which means our choices are the endpoints. Notice here on number 9, A and B were the endpoints, and we were trying to figure out the midpoint. We used the endpoints to tell us which one was x1, y1, and which one was x2, y2. We're going to do the same thing here. So between N and Q, which is x1, y1? Which one did you want, Nicole? N. Okay, Nicole wants N for Nicole to be x1, y1 because she is number 1 and so are her points. That forces us to make Q x2, y2. We're going to go ahead and substitute for what we know. We're okay so far? Okay. Now we have to solve these for the variables. And if this looks like a mess to handle, you're right, it doesn't look easy to solve right now. So let's write it in a way that is easy to solve. Okay, give me a second. I'm going to pause time for your projection screen. Ta-da! Okay. This way I can scoot it over a little bit more. It was running into my base here. Okay. This coordinate of the midpoint is which one? The x-coordinate or the y-coordinate? And this gives us information about the x-coordinate, yes? What's the relationship between those two? They're equal, which means I can write for myself an equation that puts those two values for the x-coordinate equal to each other. I can do the same thing exactly for the y-coordinates. These equations look a little easier to solve than the other one that we were working with, yes? Okay. Still complicated looking though, right? Because of that fraction. Flip the table, we give up. No, don't give up. Let me show you how to deal with fractions in an equation. What's this little fraction bar mean?
Division.
Yeah, divide, division. How do you want to do division?
You multiply.
Yeah, you multiply, because that's its opposite. So if I have here written divide by 2, what should I do to get rid of divide by 2? Multiply by 2. So I'm going to multiply this entire side by 2. And what I do to one side, I must do to the other. So I'm going to multiply this entire side by 2. The left-hand side is going to become 6. And the right-hand side is going to be just the numerator of my fraction. It's just the numerator. It's not getting multiplied by 2 because the multiply by 2 is getting canceled and is undoing the divide by 2. Okay? So it's going to feel like it's not doing anything, but it totally is. It's getting rid of the fraction for you. Now we can solve this one pretty easily, yes? Add 1 to both sides, and the value of x2 is excuse me, is 7. Repeat for the other equation, right? Exact same process. Doop, de-doop, de-doop, multiply both sides by 2 because I don't like the fraction divide by 2. Doop, de-doop, doop, doop. The caffeine is setting in. I'm getting crazier as we go. We need to get y2 by itself. How do we get rid of that? Add 5. Minus 5. And when we're done, our value for y2 is negative 19. So, whoop, our final answer is the coordinate of q is 7, comma, negative 19. It took a little bit of time. You will have some practice on it, so it will go faster for you.